notes are looking at air masses and fronts. We've been looking at these topics for a little bit in class the last couple days, so these notes are kind of serving as more of a review than anything else. So we're going to go through them fairly quickly and just make sure we're all on the same page with different definitions and terms. So we're going to start with air masses. All right, an air mass, like we said in class today, is a body of air that has similar properties to the surface it formed over. And the surfaces and the properties we focus on are temperature and humidity. And so an air mass can be either continental or maritime, and then either polar or tropical. And these are going to determine the temperature, and then the location is going to determine our humidity. And so our options for air masses are as follows. So we have types of air masses. We have maritime polar, right? And you might want to make a little table in your notes, right? Maritime polar, which we said was cool and humid. Continental polar, which we said was cool and dry. Maritime tropical, which was warm and humid. And then continental tropical, which was warm and dry. Right? Notice we have another maritime set coming from the Atlantic Ocean, but this is the same type of air mass as this. You don't need to put it again. We also have, right, continental Arctic. It's super cold and dry, but we don't see that super often affecting us in the U.S. So when two air masses meet each other, they form a front. So a front is a boundary between air masses, and they usually result in some kind of precipitation. So we're going to look at each type in order. So our two main fronts are warm fronts and cold fronts. So in a warm front, we have warm, lighter air pushing over a cold, heavier air mass. Right? And so the warm air is pushing the cold air out of the way, but as it reaches it, it kind of gets pushed up along a ramp. And this often results in hours to days of steady rain. Since this warm air rises gradually, it forms lots of clouds spread out over a big horizontal distance. So you'll get lots of areas over here where you'll have clouds. The symbol is the line with semicircles, and the semicircles tell us which direction the front is moving. So it's moving towards the semicircles. Kind of the opposite is, so like on a weather map, you can kind of tell where a warm front is, right? If we look at temperature differences. On the one side of the warm front, it's much warmer than on the other side. Our next option is a cold front. This is kind of the opposite of a warm front. And so here, cold air is pushing behind, kind of wedges itself under warm air. All right, so the warm air is still on top because warm air is less dense. But here, the cold air pushes the warm air up rapidly. And this gives us cumulonimbus clouds and thunderstorms, which we'll look at a little bit more tomorrow night in our storms notes. All right, cold fronts have these little jagged teeth symbols, right? And then that also shows the direction of movement. So in both of these, the warm and the cold front, the warm air is getting pushed up, but here it gets pushed very quickly upwards, almost vertically. Whereas in the warm front, wrong picture. In the warm front, it got pushed up much more gradually, and we weren't able, and the moisture had time to come out over a couple days. If we look at the map, a cold front, when it comes in, the temperatures are going to drop. So on this side of the cold front, you can see temperatures much lower than temperatures on this side of the cold front. All right, we have two other fronts that we're going to look at quickly. We have an occluded front. Right? This occurs when a cold front catches up to a warm front. And so we have cold air that is caught up to other cold air on the surface and trapped warm air above it. And so this occluded front is alternating circles and triangles on the same side, right, showing that the front is still moving. Right? These are not super common, and you don't need to know a bunch about these except for that it's going to bring precipitation, and you need to know the symbol for it. And then for a stationary front, right, this is a boundary between air masses that isn't moving. So neither air mass can push the other out of the way. we still have warm air going up and condensing, but this may remain in place for several days. You might get a couple days of rain. And here, notice the symbol is different because the semicircles and triangles are on opposite sides of the front line. Right? So the semicircles point towards the warm air, the triangles point towards the cold air. Alright guys, that's it for tonight. Make sure you put 3 questions at the bottom. We'll go over those at the start of class tomorrow, and we'll see you in class.